Hi everyone, welcome back to the channel. In this video, I will be covering the fundamentals of AC circuits. Now, what we mean by fundamentals means I will be considering average value calculation and RMS value calculation. So, I will be solving three different problems that will show that how to calculate the average value and RMS value and thereby the form factor and peak factor. So let's start with the first problem. Problem states find the average and RMS value of the waveform. Also find form factor and peak factor. Now if we haven't discussed the form factor and peak factor in the last video, let's discuss that first. The form factor is actually ratio of RMS value to average value. For any waveform, if we take the ratio of RMS to average, that is known as form factor, while the peak factor is ratio of maximum value to RMS value. So depending upon that what is the average value, what is the RMS value or maximum value, we will have the peak factor and form factor different for different waveforms. Now the first waveform which I am considering is the just like output of a half wave rectifier. It's starting from 0, pi, 2 pi, 3 pi. On this side we have theta. The maximum value is Vm. So it's a repetitive waveform which repeats like from 0 to pi, then pi to 2 pi, then 2 pi to 3 pi. So we have to find out its value over 0 to pi. Now how we express the instantaneous value of this? It's like Vm sine theta. So if we find out average value, then average value is T2 minus T1, T2 is pi, T1 is 0, so it's 1 by pi, integration from T1 to T2, 0 to pi, V into d theta. So 1 upon pi, integration from 0 to pi, V is Vm sine theta to d theta. Now the integration of sine theta is minus cos theta, limits are from 0 to pi. 1 by pi Vm cos of pi plus cos 0. Now minus of cos of pi is plus 1, basically cos of pi is minus 1, so minus minus plus, so it's 1 plus 1. So our average value of voltage is actually 2 Vm by pi. We can say it's 0.637 Vm. This is the average value. Next is we have to calculate the RMS value. RMS value we denote by simply V. It's under root 1 by T2 minus T1. T2 is pi, T1 is 0. integration from t1 to t2 v square d theta. So it's under root 1 by pi integration from 0 to pi v square sine square theta into d theta. Now we can't integrate the sine squared theta directly, but we can express it as 1 minus cos 2 theta by 2 into d theta, and let's write v square over here. Sorry, vm square. Take it outside. So now we can take vm square outside the square root. In denominator we will have root 2 into pi, and then under the root we will have the integration of 1 minus cos of 2 theta into d theta. Integration limits are from 0 to pi. Vm by root 2 pi, so it's theta. Integration of cos 2 theta is sine 2 theta by 2. Limits from 0 to pi. Vm by root 2 pi, pi minus 0. Sine of 2 pi is 0 minus sine of 0 is 0. So basically its value is Vm into root 2 upon root 2 pi, or RMS, sorry, it's V max, not V. It's Vm by root 2. So this one is same as a sinusoidal waveform. Now our question was also to find out form factor, which is ratio of RMS to average value. RMS value is Vm by root 2. Average value is 2 Vm by pi. This one comes out to be 1.11. Peak factor, ratio of maximum to RMS value, so it's root 2 or 1.414. Let's consider another waveform. The question remains same, that we have to find out average value, RMS value. The wave shape is different. Now the waveform is a triangular waveform. So it's repetitive, it keeps on repeating. Here we have t, starts from 0, maximum at 2, then 4, negative maximum at 6, 8, 10, 12, and so on. The maximum value of current is 15 amperes, and on this side it's minus 15 amperes. So this is the variation of current. Now we need to express this current. We have to write the equation of current. Now this is a symmetrical waveform. If we find out its average value over the complete cycle, it will be 0. So we have to find it over the half cycle, that is up to this. We need to express the current. Current will have two different values. From 0 to 2 it is increasing, then 2 to 4 it's decreasing. So how can we find out? It's a straight line. So we have to use the equation y is equal to mx plus c. So we will have slope m1 for this area and m2 for this area. So let's find out first m1, then m2. So m1 is y2 minus y1. y2 is 15, y1 is 0, x2 minus x1, 2 minus 0, it's 7.5. Now intercept for this is 0, so we can say c1 is 0. So our first equation I of t will be equal to 7.5t. Now this is for range from 0 to 2. 2 to 4 we need to find out the slope. Y2 is 0 because current is reducing to 0 starting from 15. Y1 is 15. 0 minus 15. X2 is 4, x1 is 2. 4 minus 2, it's minus 7.5. We need to find out C2 as well. Now how can we find out C2? We can find C2 by the equation that y is equal to mx plus c from here only. Like the I2, what we can say that I2 is equal to I2 is equal to M2 T2 plus C2. We can take any instant. For example, we take this instant when time is 4. At that time value of current is 0. So we can say I equal to I2, that is 0, equal to minus 7.5 into 4 plus C2. So C2 is equal to 30 from here. So the equation of current from time 2 to 4 is minus 7.5 t plus 30. So we can express the current IT as 7.5 t for 0 to t up to 2, and it's minus 7.5 t plus 30 from 2 to 4. So the main thing in this problem was to find out the equation of current. Now I average we can find out by finding out the current variation from 0 to 4. So it's 1 upon t2 minus t1. T2 is 4 minus 0. Integration limits from 0 to 4 it into dt. We need to break the integration limits from 0 to 2. Current is 7.5 t into dt, and from 2 to 4 it's minus 7.5 t plus 30 into dt. So when you solve the integration, so it's 7.5 t square by 2, 0 to 2 plus minus 7.5 t square by 2 plus 30t, limits from 2 to 4. Now when we put the limits and solve this, the value of I average is actually 7.5 amperes. You can solve this by your own. You have to just put the limits of time. You will get the answer. Second is we have to calculate average RMS value, that is I. Again, its variation from 0 T2 to T1 to T2. So that is 0 to 4, 1 upon 4, and all of thing is going to be under the square root. Integration from 0 to 4 it square into dt. So 1 by 2 outside the square root. Integration limits has to be broken from 0 to 2. From 0 to 2 it is 7.5 t square into dt. From 2 to 4 minus 7.5 t plus 30 square into dt. So it will become 0 to 2. The 7.5 square is 56.25. Integration of t square is t cube by 3. Instead of integration, it's like this, from 0 to 2. Then the integration of this from 2 to 4, 56.25 t square plus 900 minus 450 t into dt. 1 by 2 under the square root. This 56.25 by 3 is 18.75 t cube 0 to 2, the integration limits, and the integration of this part 56.25 t cube by 3, 900 t minus 450 t square by 2, with the limits are from 2 to 4. Now when you substitute these limits and solve, you will get the value of I average as 8.66 ampere. Now if we find out peak factor, which is ratio of I max to I, 15 by 8.66, this one is 1.73, while the form factor, which is ratio of RMS value to average value, RMS is 8.66, average is 7.5, so this one is 1.155 for this particular waveform. The last waveform which I am considering over here is bit different from these two. The waveform is like varying sinusoidally up to this, then constant, then decreasing like this, then zero value, then again repeating similarly. So this is 0, this one is pi by 3, pi by 2, pi, 2 pi, here we have theta, the maximum value is Vm, and this particular value is 0.866 Vm. So actually this voltage V, which we need to express, that has three different variations. From 0 to pi, voltage is 0 to pi by 3, it's Vm sine theta. From 0 to pi by 3. And from pi by 3 to pi, it is 0.866 Vm. And then from pi by 2 to pi, it is again Vm sine theta. So we need to express the instantaneous voltage like this, or we can say V is function of theta like this. So V average, as this is an unsymmetrical waveform, so we have to calculate it over the complete cycle. So T2 is 2 pi and T1 is 0. So 1 upon 2 pi, integration from 0 to 2 pi V theta into d theta. Now we need to break the integration limits. 1 upon 2 pi from 0 to pi by 3, it's Vm sine theta into d theta. From pi by 3 to pi by 2, it's 0.866 Vm d theta, and from pi by 2 to pi, again Vm sine theta into d theta. So 1 upon 2 pi. Now integration Vm is common in all of them, so let's take it outside. Integration of sine theta is minus cos theta. Limits from 0 to pi by 3. Then 0.886 into d theta integration will be 0.866 theta. Theta is varying from pi by 3 to pi by 2. Then Vm is outside, integration of sine is again minus cos theta. Theta is varying from pi by 2 to pi. Now when we substitute all these limits and solve this, we will get the value of average voltage as 0.311 Vm. This is the average value. So next step is we have to calculate the RMS value. RMS value is under the root 1 by 2 pi integration from 0 to 2 pi of V theta square into d theta 1 by root 2 pi outside, breaking the limits from 0 to pi by 3. Voltage is Vm sine theta square into theta. From pi by 3 to pi by 2, it's 0.866 Vm square into d theta, plus from pi by 2 to pi again Vm sine theta square into d theta. Now Vm square is common everywhere. So when we take it common and bring it outside the square root, it becomes Vm by root 2 pi. And under the square root, integration from 0 to pi sine square theta into d theta from pi by 3 to pi by 2, it's 0.7499 d theta plus pi by 2 to pi theta sine square theta into d theta. Again we can't integrate sine square theta, so we need to change it into the theta form, and we will replace the sine square theta by 1 minus cos 2 theta. So limits from 1 minus cos 2 theta by 2 plus integration of this is 0.7499 theta, which is varying from pi by 3 to pi by 2. Integration of 1 minus cos 2 theta by 2 into d theta over here and d theta over here also. Vm by root 2 pi integration, no, 1 by 2 into d theta is theta by 2. Integration of cos of 2 theta is sine 2 theta by 2, 2 into 4. 2 into 2, it's 4. Limits are from 0 to pi. So this one is 0.4799 pi by 2 minus pi by 3. Then again integration of this is theta by 2 minus sine 2 theta on 2 into 2, where the limits are from pi by 2 to pi. Now when we substitute all these limits and solve this, we will get the value of this RMS voltage as 0.4862 Vm. You can solve this and verify, and thereby you can calculate the form factor and peak factor. The form factor is ratio of RMS to Average value, RMS value we have calculated as 0.311 Vm. RMS value is 0.4862 Vm. So this comes out to be 0.6397, while the peak factor, which is ratio of Imax or Vmax, V maximum is Vm upon its RMS value, which is 0.4862. So this one is 2.0567. So I am hoping that these problems are helpful to you. In next video, I will solve the problems of AC series circuit. Thanks for watching the video.